Today we'll go over chapter 7, which is process strategy, and the global company profile that we have for this chapter is Harley-Davidson. I'm sure you all had at least seen, at least in the videos or on the streets, have seen those beautiful Harley-Davidson motorbikes and have seen them, how beautiful they are, how customized they are. And to learn more about it, watch the video on chapter 7's multimedia. And also please read the book on that. It's very informative and helps you to learn more about today's topic. So you will learn 4 process strategies. You will learn selection of equipment, process analysis and design, special consideration of service process design, and production technology, technology and service, and process redesign. These are main topics we'll talk about. And if we want to just take a look at the process flow diagram for making or creating the Harley-Davidson motorbikes, which are special made for different demands, right? They customize the motorbikes and make many different types. So where it starts with the frame tube bending, frame building work cell, frame machining, and then there are parts that are actually coming from other vendors, or parts that come from different factories. So they all get here together, and this is where we assemble them, okay? You can see that it says arriving on a JIT. So JIT is also used in Harley-Davidson factory. It's not as tight as what is happening in Japan. But still, yeah, there will be JIT there. And then they will assemble other parts as oil tank, and then shocks and forks, handlebars, and the rest of all parts that are required to have a motorbike. So motorbike will be ready, and then they will have testing, and there are 28. So this is not updated. This is from the time that the book was published. There are 28 tests they run. Probably if you check it today, there will be different number of tests that they require, because they always look for higher quality, right? And then roller testing, and after that, it goes for delivering to shops and customers. Learning objective. So not all of these learning objectives will be covered, but majority of them that are required for 7S. Describe 4 process strategies, compute crossover points for different processes, use the tools of process analysis, and we have describe customer interaction and service process, identify recent advances in production technology. So what's the objective of process strategy? So the objective of process strategy is to create a process to produce offering that meet customer requirements within cost and other managerial constraints. What we actually mean here by constraints is, you know that when you have a factory, or you want to produce anything, or even if you want to start a business, there's always limitations out there. So your budget might be limited. Your space might be limited, right? You might not be able to have a very big inventory space. So all these limitations are available when you start looking into your process strategy. And before starting to design your process strategy, you need to always think about what those limitations are, and don't go beyond the limitations that you have. So if your budget limitation is $1.5 million, you can't put a design and use machines and employees that require a $2.5 or $5 million, right? So that's what we mean by those costs and managerial constraints. So how to produce a product or provide a service that meets or exceeds customer requirements and meet the cost and managerial goals. So another important strategy we need to think of is customers' requirement, because at the end of the day, why are you producing? You're producing to sell to a customer. And if that customer does not buy your product, that would be a disaster, right? You will be out of business. So the first thing you need to think of is marketing and understanding what's the quality, what's the product that your customer wants, right? That's the most important thing. So, and making sure that customer is satisfied, is happy with the product, because if they're not happy, they go somewhere else and they will get what they want from another company. So you don't want to lose your sales, your revenue. And we did talk about the cost and managerial goals. Has long-term effects on the process strategy, has long-term effects on efficiency and production flexibility, and also on cost and quality. Of course, the way you put your strategy of the process affects on your efficiency. If you put a design in a way that a task might take longer than what it's supposed to be, or more costly than what's supposed to be, then you will have lower efficiency, right? You need to make sure that consider flexibility. And what we mean here by flexibility is we want to make sure if the demand of what we are producing goes up, we are capable of expanding and increasing our production. If for any reason, for some economical disaster or problem, the demand goes down, we're flexible enough to produce, but adjust it to what's required, right? And that's the same thing for cost and quality. When what you design can have directly effect on the cost and directly affect on the quality of your product. And we have talked about the quality and cost, right? The higher the quality you make at the first time, the lower the total cost. So this chart, this table, in fact, is showing some relation between the volume of production compared to variety or flexibility level of your products, right? So when you have a high variation of products with a high volume, so it's high volume, so you're actually mass customizing. And what we mean here by mass customization is that you're producing a lot for many people, and for each person, you might need to have a customized product. And that means you have to have flexible and different categories, many different categories. And a good example here is, for example, Dell computers, right? So you can see Dell computers. If you want to order it online, you go online. There are many different types of laptop, computers, PCs to buy. And also depends on the type of work you're doing. Gaming, are you doing recording? Are you doing just programming, movie production, music production, right? Depends on your needs. They have different options, more expensive or less costly. And also you can just customize yourself, select all the parts of your laptop or your computer by yourself, right? So each of these categories, you can see that they actually have different customization. For example, Frito-Lay, which is you eat potato chips, right? They are produced by Frito-Lay. So the question is, or maybe beer or steel or glass, commercial baked goods, all these are products that they are mass produced. Why mass produced? Because most people buy them, right? They have to produce a lot because most people are going to buy those products. Most people use those. So that's a high volume. On the other hand, we don't have many different types of don't know, beer or bread or potato chips, right? They are different, but each company may just create like 3 or 4 different types. And as a result, we put them under low variety. So this is low variety, this is high variety, right? So you can see the change from category to category. And here you can see the higher the volume of your product. So this is a good table just to look at and try to understand different type of businesses, where they stand. 4 basic strategies are process focus. So you either are creating or designing your process strategy based on you are a process focus producer or service provider, or you are a repetitive focus, or you are product focus, or you are a mass customization producer. Is it possible to have a combination of these? The answer is yes. It's also possible to have combination of these, 2 by 2 or 3 of them. Within the basic strategies, there are many ways they may be implemented. It really depends on the company and what they are producing. This can be completely different. Facilities are organized around specific activities or processes. General purpose equipment and skilled personnel are required. High degree of product flexibility is very good for process focus, and typically high cost and low equipment utilization, because the process is focused. The focus is on the process itself, right? That make it low equipment utilization. And product flows may vary considerably by making planning and scheduling a challenge. And that's because of the way that the product flow can be different for different productions. Example of that is hospitals, right? And I hope you watched the Arnold Palmer Hospital in the previous chapters. And so that's a very good example for low volume, high variety of processes. You have many inputs, which are your customers, your patients. Yeah, so, and what is the output of hospitals, right? So we have all of those surgeries, sick patients, baby deliveries, emergency department, all these different departments. So many different people might go to a hospital. They are spread into different departments, and the outputs, we have many different outputs, right? For each department, we might have different outputs. Some of them may stay in hospital for a long time. Some may just go home same day. Some may just go to pharmacy. Some may just need a blood test, maybe, right? So there's a high variety of different type of customers there. And the repetitive focus is next. The facility is often organized as assembly lines. And that should probably remind you of factories that make a lot of products, characterized by modules with parts and assemblies made previously. Modules may be combined for many output options, and less flexibility than process-focused facilities, but more efficient. So something that we see here is that, so you have surgeons working here, right? So for a surgeon to become a surgeon, or for a doctor to become a doctor, they have to study for many years and have many years of experience working, and then they can become. So the specialization, the amount of skills that they need is really in a high level, and that makes it very specific. That makes it being focused, right? But here, on repetitive focus, we probably have a few engineers and designers and operations research and industrial engineers working to create that, or mechanical engineers making that factory. But after that, everything is about the same thing is going to repeat and repeat and repeat. And every time it repeats, a production comes out, or a couple of productions will go out. So facilities often organized by assembly lines, characterized by modules with parts and assemblies made previously. Modules may be combined for many output options and less flexibility than process-focused facilities, but more efficient. Repetitive focus. So example for that is, we said factories, right? So one of those factories can be Harley-Davidson or car factories. And I'm sure you can imagine how it looks like, right? Raw material and module inputs go in, and we have multiple engine models and wheel modules. But they're not many, right? They're just some lines. And then we have few modules that assemble all of those raw material or parts, put them together, and then we have modules combined for many output options. So at the end of the day, depends on how many customers you have, how many customizations you have, which in Harley-Davidson case, they're highly customizing, because I can say most of these motorbikes, they are uniquely created, and you can't probably find similar to it. Then we have product focus. Facilities are organized by product. High volume but low variety of products. Long continuous production runs enable efficient processes. Typically high fixed cost but low variable costs. Generally less skilled laborers are required. And a good example of that is Frito-Lay, or creating chips, potato chips. Few inputs. You might have potatoes, water, some different types of seasoning, and also maybe corn, if they have corn productions too. They go in. The rest of the process, if you have watched the video on previous chapters, you will see that most of the parts are being done automatically using machines, and less human are involved. And if they are involved, they are less skilled, right? They're not like doctors, they're not like engineers. They're mostly, they have engineers, but not many. Most of those employees are just at a lower level of skills. And we have mass customization. So a good example was Dell laptops, but let's just see more. Here you can see it's showing some dental products, right? And when it comes to dental products, each person requires a specific need based on the size of their teeth, the way that things work for them. So we can't really produce millions of the same product. We can produce millions of it, but it has to be customized for each customer, right? So the rapid low-cost production of goods and services to satisfy increasingly unique customer desires combines flexibility of process focus with efficiency of product focus. And we did talk about the Dell computers, so that's our example. So there are more explanations in the book on this topic. Just make sure to read those stories and get to know more about this topic. On mass customization, imaginative product design is required. Flexible process design is very important, because you're mass customizing. If there is any update, any change, if there is a competitor out there that's creating a new product that people are buying that product, with a small change, you need to be able, you need to be flexible, and your design need to be flexible to convert your whole system into a new production. Tightly controlled inventory management, and tight schedules, responsive partners in the supply chain. And in the next few slides, you have the comparison of these processes. So we're comparing process focus compared to repetitive focus and product focus and mass customization. I think we went over these well enough. So just have a look into these, and it's just a repeating of what we just talked about today. So what is a crossover chart example? So this crossover chart example is giving you the process of creating software A, software B, and software C. So what we're discussing here is when you have a higher fixed cost, particularly when that higher fixed cost is associated to technology, higher level of technology, higher level of automation, and higher quality of machines that use less inputs to produce more output, more efficient machines, right? Then, or higher skilled employees, like when you have someone with a degree in maybe in computer science programming for you, or someone with a master's, someone with a PhD, or maybe we just don't talk about a degree, we can talk about years experience in programming and what type of programs they have made before, right? So of course, if you hire people with a higher level of skills, they're more costly, right? So when your total fixed cost, especially in terms of technology, goes up, the dollars required per accounting report goes down. The total cost of, we can say, variable costs. In this is a specific example, but in general, we can say your variable cost will go down. When you have less, spend less on your fixed cost, so you're using less technology and less skilled employees to produce. And as a result, for each item you're producing, there will be a higher cost to increase number of products. So if you want to scale from 1,000 to 1,000,000, it's going to be very costly because basically your total fixed cost shows that you have less flexibility, less capability of increasing your amount of production. But if your company, you decided to have a more flexible production line, you have a more flexible machines, higher level of technology, higher level of skills are provided, then requirements to increase from 1,000 units of production to 1,000,000 units of production is actually very low because you have the technology, you have the flexibility already designed in your system. Okay? So that's what this actually means. And when we go forward, you can see here in the crossover chart, that's what we just talked about. So $200,000 of fixed cost, the associated slope of the variable cost is the A, total process A. So for each unit, each additional unit of production you produce, the cost goes up with this slope or with this slope. When you have higher fixed cost, probably you have a repetitive process, and that means higher level of technology and customization in your factory. That reduces your variable cost. And when you're producing high volume, so for high volume, you have a higher fixed cost, but that higher fixed cost result in lower variable cost because the way that this design has happened, the way that the technology and skilled skills behind this mass production is happening. It's actually letting you to have a lower variable cost. On focus processes, focus brings efficiency. And one example of focus brings efficiency is that you have seen when you repeat doing something, at the beginning you might not be good at it. And the more you move forward and focus on doing specifically that one thing, you get better at it. And slowly, slowly you become innovative. So you learn by doing it, and you learn from your mistakes while doing something specific. When you're focusing on one specific thing and you get better at it, you become innovative, you become more efficient, right? That makes sense. Focus on depth of product line rather than the breadth. And focus can be on, so your focus can be on customers. You just focus on what customers want. Or for example, if it's, let's say it's a hospital, right? The focus, of course, is on customers. Focus can be on the product. Focus can be on service. Focus can be on the technology. Also, focus can be on a combination of all these. I can say that we're not covering any possibility here. This is like a majority of categories that we can cover. Then we have selection of equipments in production. So decisions can be complex as alternate methods may be available. And these alternate methods or alternate resources, they actually can create a very complex system for you to make decisions to reduce your cost. So what I can say at this point is the area that I did my master's and PhD in is operations research. And operations research, we deal with this type of complex problem. So we can have like thousands of inputs, thousands of output. Some of these inputs, outputs are in fact alternatives. You don't have to select all, but you have to select one. So the question is, which combination of, let's say we have 1,000 inputs, you have to take 10. Which combination of these 10 with a combination of certain outputs can create the highest efficiency, can create the lowest cost for you, and can create a higher level of quality and customer satisfaction. So these are like 4 factors I talked about, right? These are outputs. You want to have a high quality, you want to have a happy customer, you want to have a lower cost, you want to have a higher revenue or higher efficiency, which means you produce more with a certain amount of resources. So this creates a very complex system of mathematical equations that you need to solve it. So what we do in operations research, we collect data first, collect all the information, all the data from historical data we have, from current available alternatives that we have. And on the other side, we look into what customer wants. We look into data collection for marketing, understanding the advertising part, and all the production, different production designs, different locations that we can have our production in. So all of these become data, right? We get all this data. There's a big data. You might have like millions of rows of data. And we put this together. Now you have to come up with alternative solutions and see which of these design, you might have like 10, 20 different designs, 10, 20 different locations, right? You can imagine how many numbers, how many different alternative decisions you can make. And from there, then we come up with optimization. So what optimization means here is that we want to come up with the lowest cost highest quality and highest customer satisfaction, right? That's optimizing. You're minimizing your inputs, you're maximizing your outputs. So the question is, how can we get to that point? Which combination of all these inputs and outputs can take us to a point, and that point, we call it the optimized point, right? So mathematically, we can create equations, mathematical equations, that after solving it, the equation, the mathematical model, a statistical model can tell us which decision is the best. So that's the area that I did my PhD work on. And I actually can say that I did implement it in few organizations, and it saved millions of dollars. This can be complex, as alternate methods may be available. Important factors may be cost, cash flow, market stability, quality, capacity, and flexibility. There are many other factors involved, and the more factors you put in, the more complex your system is. The next is flexibility. Flexibility is the ability to respond with little penalty in time, cost, or customer value. Maybe a competitive advantage, maybe difficult and expensive. Without it, change may mean starting over. So flexibility in your design is very important. Always thinking about if you have more demand, if you want to change your design and start a new production, or maybe update your production, you don't want to start from the beginning. You want to put your system in a way that there is a space for adding a new machine. There is space for adding new employees, right? You need to think about those things when you're designing your process. Maybe a competitive advantage, maybe difficult and expensive. Without it, change may mean starting over. So let me, all right, so under process analysis and design, is the process designed to achieve a competitive advantage? These are the questions that you need to ask when designing your process or analyzing your process. Does the process eliminate steps that do not add value? Does the process maximize the customer value? Will the process win orders? So remember, in complex systems, when we say complex system, what do we mean? When you have too many variables involved, that you can't really manually sit and check point by point and or decision by decision and see which decision minimizes your cost or maximizes your revenue or profit or happiness of your customers, right? When minimizing and maximizing comes in, optimization is the point. So whenever we say optimization, what we mean is we create a mathematical model. This mathematical model is going to point by point check all of those decisions for you automatically. Something that if you want to do it yourself, it might take few years to check one by one. These are tens of thousands of alternatives you have in hand, and you want to see which combination is the best, right? But you program it, you write a simple program, that program using R or MATLAB or maybe using SAS. There are other like Lindo softwares. You use one of these softwares. Most part of the software is actually designed before. You just need to make a few changes to the program, and that will actually give you the best possible point, right? Will the process win orders? Or put it in a simple way, will you have more sales? And can you make revenues? That's the question. Next is process analysis and design. So we have flowcharts. We normally use flowcharts to show the flow of tasks and flow of material and flow of processes during the production line, right? And it's very important. What is the time function mapping? So time function mapping is very similar to a flowchart, but we put it on a time scale, and we show that how long it takes for a task to be completed, and which tasks can be done at the same time, and which ones are like a sequence, they have to be done after the other. So they have like a pre-requirement to be completed. So that put this into two ways. Those can be done at the same time. Those have to be done back to back. And then we count the amount of time that is required to complete tasks that have to be like a sequence, right? So we add them up, add up the time that it takes for those sequence tasks, and that would be the time it takes for us to complete the process or produce something. So this is the baseline time function map. And you can see down here, these two can be done at the same time. In 12 days can be completed, and we have a wait for 13 days. And then we have a print for 1 day, and that continues. So you can see some of them can be done at the same time. Some have to be done in different sequences, right? So where's the flowchart? So flowchart, I believe, this should be slide 33. The first slide we saw together, I believe that was a flowchart. So this one, this is like a flowchart, right? It shows the flow of processes. And if on the testing part, I would say I can add something here if there's any defects, any failures, or after roller testing, any part on the testing station, if something is not working, you can always go back to any of these stations, depend on which part has a problem, right? Or maybe we can have a repair shop and put them back into repair shop and complete the repair. Okay, so let's go back to this chart. So target time function map. So this is another example here. Then we can have a process chart. So this process chart, this can be like a daily record thing. We can just put our processes. These are showing what type of process we have. Is it transportation? Is it processing, completing a task? Is it a test? Is it checking something? Is it retaining something? And those lines that shows which part what type of function we're doing. And times in minute, we can record the time that it takes to complete for today. And then we do it for tomorrow, and then we do it every day. Maybe we can do it for 6 months, for 1 year. And you know, these are going to be your data. These are going to be your historical data. So you use your historical data, get the averages, get the standard deviation, and understand how your system works, and you will start managing your system. So that's actually a part of your data collection, but it's not always like this, like manually. You can also have sensors. You can have cameras. You can have computer programs that record everything, right? So anyway, either it's automated or manually data collected. At the end of the day, we want to use this historical data to come up with some managerial decisions in the future. So VSM, or value stream mapping, where value is added in the entire production process, including supply chain. So we can say in a big picture of what we want to say here on VSM is that we don't want to create any change. We don't want to add a new task, a new process in our design. We don't want to change our design unless that change, that additional task, create a higher value or increases your efficiency, right? So let's say you have already selected suppliers, you have already selected your design, you have already selected your material, resources, everything. And then after 6 months, after 1 year of data collection, you decide to, okay, I want to look at my efficiency and see how efficient I'm working, right? Then you decide to make this process better. To make this process better, you might want to have new suppliers, new processes, changes, new machines, but you want to make sure that if you're adding or changing anything, there's added value or there's higher efficiency or lower cost involved. One of the very important factors that we look at in REDESIGN is customers on one side, because customers bring revenue and create profit, right? And on the other side is the supplier. So these are, I can say, the most important inputs for your manufacturing management. You should always look into your customers. Are they happy? Are they buying from you? Are they satisfied with your product? If that's happening, then are your suppliers providing enough resources for your needs? That's another question. For example, if suddenly your demand goes up to, from like 20,000 goes up to 100,000 or 500,000, can your suppliers provide enough resources for you? Does your system have the flexibility or capacity to increase to that amount, right? All of these are taken into account. Transportation, shipments, operations, different tasks to be done. But again, two of those most important, we can say, factors are your customers, demand, and also your supply. So we don't cover this part. So improving service productivity. So let's look at different strategies and techniques and examples associated to it. So let's say separation as a strategy, structuring service so customers must go where the service is offered. So example of that, in a bank, they divide the bank into different rooms, right? One part, maybe on the left-hand side, you have the cashiers. On the right-hand side, you have maybe one of these cells is the manager, the other is the loan officer, the other is the, so they have different, they have a customer service, right? So they send you to the right department or right person to talk to. Strategy of self-service so customers examine, compare, and evaluate at their own pace. Supermarkets and department stores, internet ordering. So these are examples of self-service. Postponement, customizing at delivery. So customizing vans at delivery rather than at production, and focus, restricting the offerings, limited menu on the restaurants. That's the focus. Other examples of techniques to improve productivity. So modules, modular selection of services or modular production, and example can be investment and insurance selections. Pre-packed food modules in restaurants. So you have seen, there are restaurants, you go and sit, look at the menu, you just select different things that's customized, versus sometimes they have already packed sandwiches, right? You just go and grab it, pay and go, and that's it, right? So that's modules. Automation, separating services that may lead themselves to some type of automation. automation, automatic teller machines. So today you see more automation involved out there, right? Scheduling, so precise personal scheduling, scheduling ticket counter, personal at 15-minute interval at airlines. That has reduced a lot by now, right? Training, clarifying service options, explaining how to avoid problems. Example can be investments counselors, funeral directors, and after sale maintenance personnel. And then the next topic is production technology. So what technologies exist to use for our processes? And knowing them is important. Using them is also very important. Associating them to a cost and the value added is also very important. Maintenance is also very important to consider in this case. So we have machine technologies. We have automatic identification systems, AIS. We have process control, vision systems. We have robots involved, automated storage and retrieval systems. So this is a good example for Amazon. I'm sure you have seen their inventory systems. Automated guided vehicles, maybe in hospitals and also in Amazon. Flexible manufacturing systems, and maybe you can see this in companies like Tesla, companies like Toyota. Computer integrated manufacturing systems. So this is mainly seen in, today I can say it's in many organizations and many factories. A specific software I can say on computer integrated manufacturing can be SAP. That's a good software to learn for you. So machine technology increased precision, productivity, and flexibility, reduced environmental impact. Additive manufacturing produces products by adding material, not removing it. Supports innovative product design, minimal customer tooling requirement, and minimal assembly time, low inventory, and reduced time to market. AIS, a good example is when you use a barcode to scan your products that you want to purchase. Process control, so say we have sensors collecting data. We have devices that read on periodic basis. And these data collections lead to maybe a pre-programmed system that is designed already by programmers, and that control chart, looking at the control quality and the process control, and as soon as the system goes out of control, it warns you. So you don't have to be at every machine to check what's happening or record data. Everything is automated to be completed. Vision system, so particular aid to inspection, consistently accurate, never bored. That's the good thing about machines and programs, right? When we use human, they're not accurate, they're not perfect, but when you use machines and programs, they do the job and they never feel tired. Robots are the same, so they perform monotonous or dangerous tasks, perform tasks requiring significant strengths, endurance, generally enhanced consistently and accuracy. And we can say they never feel tired, right? So you one time spend and buy one of them, and it keeps producing for you. Of course, for maintenance, you need to hire at least one engineer to take care. Automated storage, I told you Amazon is the best example, and I'm sure you have all seen at least a video on that. We will talk about Amazon in the future too. Automated guided vehicles, good example, hospitals, hotels. You can see that brings all of those towers for you, right? Flexible manufacturing system. Computer controls both the workstations and material handling equipment. Enhance flexibility and reduce waste. can economically produce low volume but high variety, reduce change over time, and increase the utilization. And that's one, computer integrated manufacturing, CIM, extend flexible manufacturing, backward to engineering and inventory control. So that's very important for inventory control, actually. Forward into warehousing and shipping can also include financial and customer service area. Example of computer integrated manufacturing is when you as a manager, let's say you're a manager, you decide to create a product, make a product, right? So you start working on computer, doing research, designing everything. And on the other side, you have your project management design, which is the scheduling, resource assignment. And on the other side, you have your machines, automated machines that start creating the product. And then you have your inventory management involved. Robots are, you also have all these technologies for services, such as financial services, education. A good example that we're just doing it right now, Zoom and Canvas, right? Utilities and government, restaurants and food. So all of these, you have seen technology involved in services as well. So process redesign, the fundamental rethinking of the business processes to bring about dramatic improvement in performance relies on re-evaluating the purpose of the process and questioning both the purpose and the underlying assumptions, requires reexamination of the basic process and its objectives, focuses on activities that cross functional line. And any process is a candidate for redesign. So we always keep checking performance, keep checking our activities, and if there is any option to improve our process, we will always think about that and work on that and invest on that.